Hi class, in this video here we're going to look at section 1.8 of the text, and this section is called higher order derivatives. Alright, so let's start with this. Suppose you're given this function, okay, or consider the function given by y is equal to f of x, and it's equal to x to the fifth power minus 3x to the fourth plus x. It's just some polynomial function. Its derivative, f prime of x, okay, is given by, so it's y prime is equal to f prime of x. And just use the general power rule, right, to find this derivative. This 5 comes down, and the derivative of x to the fifth is 5x to the fourth. 4 comes down, 4 times minus 3 minus 12, x, the 4 becomes a 3. And obviously the derivative of x is just 1. So this derivative function, this f prime of x right here, can also be differentiated. Okay, which means what I'm saying here is you can find the derivative of the derivative function. So we can think of the derivative of f prime of x as the rate of change of the slope of the tangent line, right? So the first derivative, f prime of x, gives the slope of the tangent line. And then this derivative of the derivative, okay? So derivative of a derivative gives the rate of change of the slope of tangent line. So it can also be regarded at which the rate of the first derivative is changing. Okay, so the second derivative tells us the rate of change of the first derivative, if that helps. Okay, so we use this notation for the derivative. So we use this f. Notice how it has two prime signals here. So this just means the second derivative, double, double. All right, for the derivative of the derivative. Okay, so that is that f double prime of x here. That's how I will say this. Okay, instead of saying f prime, I say f double prime here. So we call f double prime here the second derivative of f. So it's the second derivative of the function, right? So we can take the first derivative, which is f prime. So f prime is the first derivative. And this f double prime is the second derivative. Okay, so going back to our function, we saw that the first derivative, f prime of x, was 5x to the fourth minus 12x cubed plus 1. All right, so what is the second derivative then? So that's f double prime of x. Well, you're just going to take the derivative of the first derivative. So the 4 comes down, so 5 times 4 gets me 20x cubed, minus 12 times 3 gets me minus 36 x squared, and the derivative of 1 is just 0. And this is our second derivative right here. So going back, you can expand on this, right? So just so we recall here, first derivative f prime of x was 5x to the fourth minus 12x cubed plus 1. Minus 12x cubed, sorry about that. And the second derivative, f double prime of x here, was 20x cubed minus 36x squared. So you can continue on this manner. You can find the third derivative, the fourth derivative, and the fifth derivative, okay? So if you just take the derivative of this, right, the 3 times the 20 gets me 60x squared, 2 times 36 minus 72x, and then so on. The derivative of the third derivative is called the fourth derivative. The derivative of this function then just becomes 120x minus 720. And then the derivative of the fourth derivative is called the fifth derivative, and it's just 120. So when notation like this gets really lengthy, we abbreviate with using a symbol in parentheses, so something like this, f to the n. F n prime x is the nth derivative. So you could write this as f3 of x. That would mean the third derivative. Or this would be f to the fourth x, and so on. So when you see things like that in this class, that'll tell you what derivative is. Generally in this class, the only things we'll use as we move on is the first, second derivative. Sometimes we might use the third derivative, but it's really our analysis is going to be on what does the first derivative tell us, and what does the second derivative tell us? And not in this lecture, but in future lectures, you'll see that the second derivative, especially when we get to curve sketching, tells us has to do with something called concavity. All right, so we know this notation. We've used it before. And the Leibniz notation for the second derivative of the function is written like this. So the first derivative, using this notation, was written as dy dx. Okay. The second derivative, we write using this notation here. It's telling us take the second derivative of y with respect to x twice. Okay, so the second derivative of y with respect to x, and this tells us the 2, whenever you see this 2 here or here, it is not an exponent. That's an important thing. So the third derivative written this way, you would write it as d3y dx cubed, and so on and so on. Okay, that's how you would use this Leibniz notation for this. All right, let's just spend some time. This is using the Leibniz notation here for the first, second, third, fourth, and fifth derivative from our example, just so you can see it. But what I want to spend the rest of the time on this lecture is I just want to work some examples so you can see how this is done. And it's very, very straightforward process. Okay, so this one here. So we got y is equal to 1 over x, and I want to find the second derivative of y with respect to x. All right, so it helps to rewrite this y is equal to rewrite this as x to the negative first power. So the first derivative, you got to find the first derivative before you can get to the second derivative, right? You bring the negative 1 down, and this becomes x to the minus 1, or minus 1x to the minus 2, or just minus x to the minus 2, or you can even write it as that, like that. Now the second derivative, using this notation here. So I'm going to use this one. So it's the derivative of this right here. So bring down the negative 2. So this is negative 2, x to the minus 2 minus 1. So negative becomes positive, like that. And so you can see this is the first derivative. And here is the second derivative. And I just, I made the negative exponent positive using the rules of exponents. And all the real trick here was just to rewrite it in such a way that you could use the power rule. That was it. All right, let's try this one. All right, so this you're going to have to use the chain rule. Okay. So let's find the first derivative and the second derivative for this function. F of x is equal to 2x to the 5th power plus 1 to the 10th power. Yikes. All right, so the first derivative. So we saw this in the previous section. You're going to bring the 10 down in front. You're going to leave the inside alone. You're going to make the 10 and 9, right, using the power rule. And then you're going to take the derivative of the inside. Well, 5 times 2 gets me 10x to the 4th power. So I'm just going to clean this up, right? 10 times 10 here gets me 100, x to the 4th power, okay? And then times 2x to the 5th plus 1 to the 9th power. Okay, now here's the thing. When you go to find the second derivative here, you're going to need to use the product rule, okay? All right, so f double prime of x. You leave this alone. Now you need to take the derivative of this. Well, you know what you're going to have to do? You have to use the chain rule again. So bring the 9 down in front. Leave the inside alone. Make the 9 and 8. And then take the derivative of the inside, which is again 10x to the 4th. Plus, take the derivative of this now. Bring the 4 down in front, so it's 400, right? x to the third power, and then this stays by itself. So what you just have to do, unfortunately, sorry, go back. What you have to do, unfortunately, is just clean this up, clean this algebra mess up, right? So it's a little crazy, right? 100 times 9 times 10 gets you 9,000. X to the fourth gets me x to the 8th times 2x to the 5th plus 1 to the 8th power plus 400x cubed times 2x to the 5th plus 1 to the 9th power. So it's a little crazy here for this one. The numbers got big, but you just have to follow your rules. Follow your rules. Yeah, I'm going to use the product rule, and then when I get to find the derivative of this, I have to use the chain rule again. All right, let's do a couple more here. All right, we'll do these 3 examples so you can see this. So it says find the second derivative for the following here. All right, so again, here, you start by finding the first derivative, y prime. So bring the 4 down, right? 4 times minus 6 gets me minus 24x cubed. All right, 3 times 2 gets me plus 6, and then x squared becomes just x. So then you're going to take the derivative of this again, right? So y double prime. So 3 times minus 24 gets me minus 72x squared. And the derivative of x is 1, so just plus 6. Here, to be able to find the second derivative here, you rewrite this as the following. 2 times x to the negative 3. So y prime, power rule. Bring the 3 down. 2 times minus 3 gets me minus 6x. Minus 3 minus 1 gets me minus 4. Y double prime, bring the, watch this. Negative 4 times negative 6 gets me positive 24. And then minus 4 minus 1 gets me x to the minus 5. So this is just 24 over x to the 5th power. All right, how are you going to tackle this one? Well, so let's use y prime. Okay. So you can chain rule this. Okay, bring the 2 down in front. Leave the inside alone. The 2 becomes a 1. All right, and then you take the derivative of the inside. Well, the derivative of 3x squared, bring the 2 in front, just gets me 6x. Right, so this becomes 2 times 6x. That gets me 12x times 3x squared plus 1. So the easiest way to do this, so one of the things you might look at this and say, okay, when I go to find the second derivative, let me chain rule this. But it's actually just like easier to distribute first, right? So 12x times 3, 3x squared gets me 36x cubed, and then 12x times 1 gets me plus 12x. So then the second derivative, right? 3 times 36, right? So what does that get us? That gets us 108, and then x squared, and then the derivative of x, remember, is just 1, so plus 12. So all you have to do to find these problems is just follow your rules of taking the derivative. So just treat the first derivative as a function, and it's just like if you want to find the second derivative, you're just finding the derivative of that. And I'll even just as a quick follow up here, right? Like let's just find y triple prime. So the third derivative here. So just from this, just so you can see how it's done, right? So the third derivative here, I would just take the derivative of this. So 2 times this would give me 216x. And then the derivative of 12 is 0. And then you can even find the fourth derivative, right? The derivative of this is just 216. And then the fifth derivative, 1, 2, 3, 4, 5. Well, the derivative of 216 is just 0. So you can see, right, like, just following your rules. Just take the derivative of the derivative, derivative of the derivative, and so on.